Okay, so this is our fan speed control project for the class EE2583, aka Microcomputer Systems 1. This is our final project for the spring 2025 semester at the University of Texas at San Antonio. All right, so what do we got here? So we're using the PIC 16F1829 chip on this custom board for the class. The peripherals we're using are these capacitive touch sensing buttons, push buttons, as well as I2C and a few other peripherals. Over here we've got potentiometer that we're going to be using, as well as a photoresistor and a temp sensor. This is the snap programmer for this board, for this chip. All right, and this is an LCD display. As you can see, we've got 16 pins over here, but we've got a expander module on the back here where we convert this down into only 4 pins for I2C. As you can see, you've got the SDA and SCL pins right there. All right, so, and here we've got a CP2102 dongle for the UART connection to PuTTY. So let's open up PuTTY. All right, so let's hook this guy up. All right. So here is the demonstration now. So it's all reset. So now, as you can see, fan status is off, 0 duty cycle, and yeah. So now we hit RB7 to put it into mode select. As you can see over here, outputting, select your mode. So we've got P for potentiometer, T for temperature, F for fixed, aka our preset buttons, which are going to be these capacitive touch sensing, and then we've got O for off. So we are going to put P. All right. And now we've got fan on. So on, duty 1023, mode potentiometer, RPM 950. So this fan over here actually does have a Hall effect sensor, but unfortunately we could not figure out how to make that work. So we took the specs from the website of this fan that the max RPM is about 950, and we just came up with a function to estimate RPM. So that's a rough estimate. So now if we go ahead and change this, changing the potentiometer, RPMs go down and the duty cycle goes down. Here, I'll twist it down some more. Duty cycle is decreasing, and eventually we are going to reach a stall point around 300-ish. Yeah, and it starts stalling out. All right, so now we're gonna hit RB7, and again, select our mode. Now we're gonna go into temperature sensing mode. So temps reading 24, 23, so there is a 300 duty cycle there, but as you can see, it's stalling out. If you give it a little push, didn't kind of work. But so this PIC program actually gets pretty hot. So we aren't using this external temperature sensor. We're actually using the internal one on the PIC. So let me try to warm this up with my finger. You can see temp is going up, and it's wanting to go. Maybe it's a little. Yeah, so we will have to calibrate that. Maybe we need that temperature threshold a little higher. All right, so let's go to the next mode. Hit RB7, select our mode. Now we're gonna go to fixed mode. All right. Now we've got these set at 25% duty, 50, 75, 100. So right here we're on 256 duty cycle. hit T. We're bumping up to 512. As you can see, it's still stalling out. If it's already in motion, it'll continue in motion, but from rest, it takes quite a bit more. So now we're gonna go to S, put it in 768, good speed, and then a nice clean duty cycle 1023 maxed out. All right, and then let's reset it. Select mode, and then we can just hit O for off. That's gonna shut it down. Now you can see mode off. I forgot to show this. Okay, I'm gonna put it back in potentiometer mode. As you can see, we've got the readout here. Mode potentiometer. And we're gonna turn that up actually. There we go. And then if we go back to say temperature, oops, mode select, temperature. Now we are in temperature mode. And as you can see, since it was already in motion, the duty cycle is at 300, but it actually continues. From rest, it needs about 600 or 700 to start from rest, but 300 duty cycle can sustain it when it's already in motion. So yeah, and we've got the fan is powered by 12 volts from this power supply, and we're using the L293D H bridge. And yeah, that is about it. I guess I could run through the code real fast. So this actually, we actually get pretty close to, let me unplug this. We actually get pretty close to maxing out this, the 8K of program memory with all this. So here are our configuration settings for the PIC, our includes, our defines, all of our initialization functions. As we know, C is a one-pass reader, so we have to define all these that are going to be, we'll later define it more in depth, the whole function. And here's our interrupt service routine, used for changing the modes. Here's our main, got our UART configurations, setup comms, clock and pin config, our I2C configurations, and we actually did have to include the I2C header files and I2C LCD. All right, and then we've got the, right here, we've got the initialization for the capacitive touch sensing buttons. Here's our infinite while loop. So the printf is going to print out to the serial monitor through the UART to my computer, as we were looking at. And this is the, these are the calls to the LCD. And then we've got our switch modes, case P for potentiometer, T for temperature, F for fixed capacitive touch sensing, and then O for off. And then, yeah, we've got all of our PWM timer config, display, clock and pin config. Also setting up RX and TX for UART, as well as, oh man, there's a lot in there. PWM initialize, PWM duty, A to D initialize, A to D read, temp read, UART config, setup comms, and the rest of these are for, these three are also for the UART, and then our temperature duty. And that is it. And that is our project, and we will be presenting tomorrow.